Hello, my name is Paul Norris, and I'm doing part two of Project 2. Um, right here, I am responsible for plotting the wall shear stress, skin friction, getting the plots onto Excel. So that's what I'm gonna do. My partner, Parneet, did part one, and we're just gonna run through that real quick. Right here, he did the geometry. He did all of that, He did the meshing right here. Then this is where my part comes in. So, first thing that I'm gonna want to start with is go to the XY plots. We want to get um, the plots for 25, 50, and 75. Um, so, let me pull this back up. Yeah, so I'm gonna get the plots for 25 centimeters, 50 centimeters, and 75 centimeters. So I'm gonna begin by right here. Obviously velocities. We want to do the x velocity. Um, all of that looks good. Um, yeah. Then we're gonna focus on line one real quick. So we select line one. I'm gonna write the file. You write it. Here I'm gonna save it to my downloads. Ooh, let me not do that. Let me not do that. Get out of there. Alright, we're there. I'm just gonna call it velocity 25. What's going on here? Velocity 25.xy. Then I'm gonna save that one. Then we're just gonna want to do the same thing for line 2 and line 3. So same exact thing. Velocity 50.xy, because that's what line 2 is at. Then line 3, gonna write it. We're gonna call it velocity. Velocity 75.xy. Bang. Now that we have all of that, that's what we're gonna need for part B right here. And I'm gonna open all of that up in Excel. Actually, I'm just gonna do it all together, just to make it simpler. And I'm just gonna put on different sheets in my Excel. So um, for part C, they want the wall shear stress and the skin friction coefficient. So what I'm gonna do there is yes, I'm gonna select flat plate. I want to switch this to wall flukes. Then this is going to be skin friction coefficient. Start off with that one. Um, we call it skin friction dot xy. Wow, skin fric dot xy. Just do that. Then yeah, they want the wall shear. So same exact thing, flat plate, the wall flukes. Then we just switch this to wall shear. Perfect, right? I'm just gonna call it wall shear dot xy. Wall shear dot xy. Perfect. That's all done. We're just gonna open all of this on Excel. I'm gonna run the Reynolds number and everything too. The boundary layer thickness and the skin friction I'll calculate while I open all these up. Give me 1 second. Alright, bang. Now I got everything uploaded right here. All the data I need. Alright, so first you're gonna want to start with the plots. So X, Y. Just insert, I guess we'll do scatter plot here. Graph looks about right. Then we want to calculate the data here. So the first thing I did was the Reynolds number right here. I just used a formula and plugged it in right here. 1.2 times 2 times 0.25, because that was our velocity. All over all over the drag coefficient, which we're giving. The viscosity there is 1.8 times 10 to the negative 5. So we use there. So when I plug that in, click enter right here, you get 3. Alright, that looks about right. Now we want to get the boundary layer thickness. So I plugged in the formula here, 5 times 0.25 all over the square root of our Reynolds number, which we got right there. Then we get 0.06847. Then we want to do these same exact steps for 0.5, 0.75. We insert, bang, we got those charts right there. Same exact formulas right here. You just switch it because the velocity changes, and same exact thing for the boundary layer thickness. We do it for 0.75 too. Just go here, insert, bang. Unfortunate. Just get right back to it because I had deselected. Insert, scatter, bang. Right here, same exact thing. Switch it to 0.75. We get that as a Reynolds number. Then the boundary layer thickness right here, E. And bang. So this is how our charts are going to look like based off our data. Then we have the skin friction here. Skin friction is going to highlight, insert. Messed up again, my fault. Insert, bang. We get our scatter here. And that's exactly how it's going to look like. Right now we're on part C, where it asks to plot the wall shear stress and compare with the theoretical ones on the same graph for both. So that's how it looks like for skin. Now for shear, I'm gonna insert it again. Let's redo that. Bang, there we go, fixed it. Now that all looks good, now we're on the final part here, where I'm asked to get the drag coefficient for the flat plate using Fluent. So that'll be our part D right here. So, alright, now that's for part D. We want to go back to Fluent. We want to go to reports right here, forces. We select flat plate 100, sounds about right. Then we click print. Bang, and we get these numbers right here. From there, we're just gonna plug that right back into Excel. So, bang, fast forward. Now that we get that, these are the numbers we were given from Fluent, from Enzius, and it's asking us to compare it to our theoretical ones on the table. So, same exact equation here. We're gonna find theoretical drag and Reynolds number. So we're gonna do 1.2 times 2 times 1. So that's we're given, and then all over that. Nothing changes with that. Over point. Let me go back here. No. Let me just do this real quick. Go back to velocity. Right here, we copy this. Bang. So, once we get that, we're just gonna solve for theoretical drag right here, and we just plug it right back into E2, and we notice that the theories are extremely close, but our fluent is pretty off. Um, it's usually how it is. We might have flipped our graphs, but besides that, that looks perfect, and I believe that is everything that we need for part 2 of the project. Thank you. This is part 2, project 2. Bye.